Hello everybody, this video clip is the 7th video clip for our chapter 3 of the course Calculus for Business 2. Okay. Previously on your Calculus 1, you have learned the so-called chain rule, which is state that if your y is a function of u, however your u is a function of x, then actually you can regard your y as a function of x, right? And you can find dy by dx, a derivative of y with respect to x, by go through the u first. Okay, so you find dy by du, and then from u go through the x, so it is du by dx. And if you look at it this way, in terms of just pretend that these two are fractions, then it seems that your bottom and your top here cancelled, and you have your dy by dx as what you need on your left hand side. Okay, so this one, if you try to draw it as a diagram, you see that your y depends on u, and then your u depends on x. So I mean, to reach the x, you need to go through u and then go through x. Okay, as an order like this. However, in our calculus 2, okay, we may start from, instead of a function of a single variable u, it may be a function of u and v, and then this one, instead of u is a function of x alone, then u may be a function of x and y. Okay, so our diagram will be larger. Okay, so let us take a look at our chain rule. Okay, so this one, as I told you, if your z is a function of two variables x and y, and at the same time your x is a function of another two variable r and s, and your y is another function of two variable, same thing, r and s. Okay, so it means that if you need to draw a diagram, your z depends on x and y, your x depends on r and s, your y also depends on r and s. Okay, so this means that actually your z depends on r and s as well. So what we can find is a derivative of z with respect to r. Okay, however, if you need to reach the r, there are two possible ways to reach the r. The first way is to go through the x. The second way is to go through the y. So what we are going to do, we are going to look at it as a combination. Okay, so as a two possibility that you are going to combine together. So the first one, you're just using the same old chain rule idea. So you are going to find dz by dx, and then followed by dx by dr. So here is what you have on your first possibility, and it seems that your dx and dx cancelled, so you got dz by dr as a result on your left hand side that you need. Okay, and this one as well, if you go through the y first and then followed by dy by dr, so on this one you got also the one that you need. Okay, and don't look at this addition as the really addition, but just take a look at it as a combination. Okay, so it means that this case you also have the left hand side that you need, and another case you also have your left hand side. Okay, so it seems that you have two contributions, okay, combined together. All right, so if you look at another way around, if you need to find dz by ds, okay, it will be the same idea that you have two possibility to reach the s. One is through the x and the second is through the y. Okay, so it means that you can use your chain rule dz by dx followed by dx by ds. Look at it this way. You see, this first possibility gives you your left hand side, and the second possibility you go through the y and dy by ds. If you cancel it here, it will give you your left hand side as well. So these two contribution, or these two possibility, will combine, okay, to get what you really need. All right. For example, let's take a look at this one. If your z is x squared plus 5y, your x depends on r and s, your y depends on r and s. Okay, you are going to find dz by dr and dz by ds. All right, so first one, dz by dr, okay, we just use this. I mean, as you work, okay, we encourage you to draw this diagram, okay. Usually the diagram helps me a lot. For example, if you need to reach the R, you see that, hey, there are two contributions, okay, so at least we got two terms to be added. All right, so this one, it is dz by dx and dx by dr together with dz by dy and dy by dr. Okay, so let's look at it. Dz by dx, so we concentrate on this one. So you have 2x, and then dx by dr, so you look at this one. So the derivative go directly to your r, so it will become 1, right? This one, dz by dy, look at this one again, so you have a 5, and then dy by dr, so you've got a 2, right, out from it. Okay, and here is a good final answer. So usually in our problem, we will indicate pretty clear that you are going to give your answer, so okay, in terms of x, y, r, s. So you don't need to really plug in your x into the r and the s again. Okay, so this is, I mean, this is why we use the chain rule. Otherwise, we are not going to use it, right? So we need to simplify the problem. So here is a good looking final answer already. Let's look at the second one. If you need to find dz by ds, so you have dz by dx, okay, through this one first, and then dx by ds, and dz by dy, followed by dy by ds. Okay, so dz by dx, can you notice something here? They are the same. There they are, I mean, they'll be the same always. So it means that if at the beginning you did it right, then you don't need to calculate it again. So this one, it must be 2x. Okay, the only one that will change is the one follow. So this one, you are going to find a derivative with respect to s, so you have a r instead, and then this one will be just 5, okay, as it is, and then the derivative with respect to s, so you have a 3, okay, and then this one will be a good enough final answer. All right, okay. So again, if you don't like my handwriting, then you can just, you know, having this one typing, and as I told you, this one can regard as your final answer. You don't really need to go to this one. All right, let's take a look at another example. So, okay, as I told you, we encourage you to draw a diagram. Okay, so your z depends on x and y, your x depends on r and s, your y also depends on r and s. So if you need to find the derivative with respect to r of the z, so it means that you are going to go through this one, and you are going to go through this y. So you have dz by dx, dx by dr, and dz by dy, and dy by dr. Okay, the dz by dx, okay, just this one, so you have 5x fourth, and then dx by dr, so here it is 2r, dz by dy, it is 14 y 6, and dy by dr, it is 6. Okay, and again, here is a good looking final answer already. How about your derivative with respect to s? So you are going to go through the first path through the x, and the second path through the y. So you have dz by dx again, and then dx by ds, dz by dy, and dy by ds. Okay, so here it is the same thing. So you got 5x fourth, but then this one, you are going to find a derivative with respect to s instead, which is -3, and this one, same thing. So you got 14y6, and dy by ds, right here it is 10s. Okay, and here you can stop. All right, okay, and this one is the typing version if you like. Okay, What if, I mean, instead of 2 variable at the beginning, you got 3 variable dependent, okay? So W depends on your X, Y, and Z. Your X depends on another 2 variable R and S. Your Y also R and S. Your Z also R and S. So, I mean, if you use the same idea, to reach the R, you need to go through the first contribution along the X, the second along the Y, and the third one along the Z. So it means that you are going to use, 3 terms added, okay? So you just have more contribution, that's it, all right? And again, this diagram will help you a lot to, figure what are we going to start, and then what are we going to follow, okay? For example, this one, okay, this is just the one that we got as above diagram, okay? So your W depends on X, Y, and Z, and the X and the Y depends on the R and the S, okay? So if you need to find W sub R, so we need to do 3 contribution, which is dW by dx, you see, this one, and then dx by dr, dW by dy, dy by dr, and we still have another contribution which is through the z, so it is dW by dz, dz by dr, okay? And each and every term is not that difficult, right? So to find a derivative with respect to x, you got y and 4xz, okay, the first one. Derivative of x with respect to r, so you have a 2. Now a w with respect to y, so you have this one, and y with respect to r, so you have 2rs cubed, and the derivative of w with respect to z, so you have 2x squared, and dz by dr, so you have a 4, and you can stop right there. Another one that you may need to find is the derivative of w with respect to s. So again, go through the x and dx by ds, and go through the y, followed by a derivative of y with respect to s, go through the z, followed by dz by ds. Okay, so the first one, it is the same thing, right? So you just copy what you have done before, but now dx by ds, so it's right here, which is 1. The second one, it is the same thing, just copy what you have, and dy by ds right here, it is 3r squared s squared, and dw by dz, it is the same thing here, 2x squared, and right now dz by ds is right there, which is -3, and you can stop here, okay? So this one, it is a derivative of w with respect to r. All right. Again, if you don't like my handwriting, you can just take a look at this one, okay, for typing version. All right. Another problem that you may encounter is that, I mean, first, your w depends on 3 variables, x, y, and z. But then each of the variable x, y, and z depends on a single variable t. So it means that actually your w depends on a single t. So it is a function of 1 variable. So to find a derivative, you are going to use a straight d, you see. So that's why you use a straight d, because it is a single variable t here. Okay. However, to reach that t, you have to go through, 3 contribution. The first through the x, the second through the y, and the third one through the z. So you are going to find dw by dx followed by dx by dt. And you see this one indicate that your w depends on several variables, but your x depends on only a single variable. So we use a straight d. This one as well, dw by dy, using a curve so that you indicate that w depends on more than 1 variable, okay, x, y, z, but your y depends on only a single variable t. And the last one, dw by dz multiplied by dz by dt, this one use a straight d. Okay, so let me just highlight it, that here they are all straight d because it depends on only a single variable t. So for example, if you need to find I mean, if your W is 2x plus y squared and xz, your x is t squared, your y is 1 minus 2t, and your z equals to 3t fourth. If you need to find dw by dt, okay, so the first one, you need to find a derivative, okay, a derivative of w with respect to x, and then dx by dt. And the second one, you find dw by dy, dy by dt, and the last one, dw by dz, and dz by dt. And I did a mistake here because, as I told you, it is a single variable, so we need to use a straight d instead of the curve. Okay, so dw by dx, here is the x, there is the x, so you got 2 and z, and this one, the derivative with respect to t, it is 2t. This one, derivative with respect to y, here is the y square, so you have 2y, and your y with respect to t, you have negative 2. And the last one, a derivative with respect to z, so here's the z, so the derivative will become an x. And this one, the derivative of z with respect to t, so you have 12t cubed. Okay, and again, this is a good enough to be your final answer. You don't need to simplify or change your x, y, z into a t. Okay, this one will be, I mean, your final answer. How about the other way around? I mean, at the beginning, it seems that your y depends on the x. Okay, however, your x depends on r as t. So it means that actually your y is a function of r, s, and t, right? So what you can find is the derivative of x with respect to, derivative of y with respect to r. And you got the only way, you see, the only way to reach that r. So it means that you must go through dy by dx and follow by dx by dr, just like that. And use this one as a straight d because here you got a single variable dependent. Okay, and same token, if you want to reach the s, so you still need to go through the x and then dx by ds, just like that. And the last one, it is dy by dx followed by dx by dt, which is dy by dt. So for example, if your y is a square root of x, but your x depends on r squared, 2s fourth, 3t squared, you can find dy by dr, okay, by using that formula, which is what, dy by dx and then dx by dr. Okay, and because your y is a square root, so it is x to the power 1/2. So your dy by dx is just simply 1/2 x raised to the power negative 1/2, which is 1/2 square root of x. Okay, so this one, you see, is fixed. You see, it's all fixed, the same thing, because you have your dx by dy by dx all the way. Okay, however, a derivative of x with respect to r, this one you got 2r. Okay, this one, it is dy by dx followed by dx by dt. Okay, so the derivative with respect to t, you got 6t, and this one, it is dy by dx followed by dx by ds. So a derivative with respect to s, you have 8s cubed. Okay, and again, all these are your final answer. All right, so this is how we use the chain rule, and we expect you to do this kind of exercise, 4 of them. Okay, so that as we see you guys in the during the class, then we can discuss about all this exercise. All right, let us go to another example. Okay, this one, it says that manufacturer of the cameras and the film, okay, saying that a total cost of producing these many cameras and these many units of film is given by 30 QC, 0.015 QC QF plus QF plus 900. Okay, so this one is the cost, depends on a number of cameras and the film that you produce. Of course, the QC and the QF depends on the demand, right? So the demand depends on the price of each, I mean, of each item. For example, your QC, okay, it is given by 9000 over PC and the square root of QF. However, your QF, the demand for the film, it is 2000 minus the price of the camera minus 400, the price of the film. Okay, so what you need to find is to find the rate of change, okay, of the total cost with respect to the price of the camera when your price of the camera is 50 and the price of the film is 4. So what does this mean? The rate of change of the cost. So it means that you are going to find DC, and this one say pretty clear that it is with respect to the price of the camera. So what you need to find is DCD with respect to the price PC. Okay. However, if you look at it carefully, you will see the cost actually depends on the number of camera that you produce, depends on the number of film that you produce, and then the number of camera that you are going to produce depends on the price of the camera and the price of the film. This one as well depends on the price of the camera and the price of the film. So if you need to reach this one, okay, you are going to go through the first contribution with the QC and the second contribution with the QF. You see, so you are going to use the chain rule. All right, so let me just rewrite this one first. Here it is so that we are easy to find a derivative, right? So here raised to the power -1, there raised to the power -1/2. Okay, so it means that if you want to find DC with respect to the price of the camera, you are going to go through the QC first and then QC with respect to the price C. You see here to there, and then another contribution that you see with respect to the F, and then the quantity of the film with respect to the price of the camera again. Okay. So first thing, if you need to find DC with respect to a quantity of the camera, so you see here is a QC, so you have 30 and 0.015 QF. Okay, and then look at the demand with respect to the price C. So it's right there, right? The price of the camera. So you got -9,000 PC raised to the power -2, PF raised to the power -1/2. Okay, and then added with your the derivative of cost with respect to QF. So here is the QF. Okay, so you have 0.015 QC and 1. Okay, and the derivative of QF with respect to the price C is right here, which is -1. Okay, but then you are going to find DC with respect to the price C at the price of the camera is 50 and the price of the film is 4. Okay, so it seems that, hey, this one is the price of the camera, right? So you can just plug in 50, and this one you can just plug in your PF to be 4, right? However, what will be your QF and the QC here that you need to also plug in? Okay, so it's not that difficult because your PC is 50 and your QF is 4. You can figure the QC by this relation. You see this relation? So it is 9,000 over your PC, which is 50, and your square root of PF, which is 4. So it is I mean at the bottom it is 100, right? So it is 90 for your number of camera. How about your film? Your film, it is 2000 minus your PC, which is 50, and 400 and the square root of 4. 400 multiplied by 4, okay, as a PF. So here you got what? 2000 minus by 1650, right? So you are going to end up with 350 for the film, all right? Okay, so as you know everything, you can determine that your the PC, when your PC is 50, your PF is 4, it just simply 30 and 0.015 multiplied by your quantity of the film, which is 350, and then multiply by minus 900 over your price of the camera square and over your square root of the price of the film. Okay, just like that, and minus, you see a minus 0.015 and the price, the quantity of the camera, which is 90, and add the 1. And then you can just simply use your calculator, right, to calculate this number. So this will be the rate of change of the total cost with respect to the price of the camera at this price level. Okay, so of course we encourage you to find another one by yourself. Okay, so to find DC with respect to the price of the film at this price level as well. Okay, so what is that rate of change? Okay, and as you take a look here, I guess because this one you have a negative, this one you also have a negative, then the rate of change, okay, is going down. So let's see what is that number. Okay, the number is negative 65.8. Okay, it is negative 65.8. Okay, dollars per unit. Sorry, it is actually dollars per dollar, so it has nothing. But what does this mean? Why the price is going down? Well, what do you think? Why the cost, not the price, sorry, why the cost is going down? Because you're talking about the rate of change of the price of the camera, right? So it means that right now your price of the camera is going up, okay? But because this one is negative, then the cost of production is going down. Why is that? Because if the price of the camera is going up, then people don't buy a camera, right? So you are going to decrease your production of the camera. And if people don't buy a camera because the camera and the film need to use it together, so people don't buy a film as well. So if the production level of the camera and the film going down, of course the cost of production will go down, right? So this one, if the price is going up by a little bit, then the from the level of 50 per camera, okay, then the cost of production will decrease by $65.8. Okay, we get. So we are going to stop our clip right here, and then we hope that as we see you in class, then you guys already watch the video clip, and then we'll learn from that. Okay, so we'll see you then. Bye bye.